So last time I wrote a bunch of unit tests for OR, exclusive OR, and. So that's and. That's quite hard to say. Anyway, and exclusive OR and logical inclusive OR. So we've got a bunch of unit tests for those, and you can see them there on the left. They are all failing. Don't know if they're good unit tests yet, but they are tests. This time what we're going to do is just implement them and see if we can get them working. So just going to take them one at a time, starting with and we should be able to implement these reasonably quickly. Because all of these addressing modes have already been done before. Also, we've already implemented we've already got all the opcodes in code, like we've actually got the values for them. So it should be a case of just going through each one and just doing this. So in the case of, so we've got and we start with immediate there. And we go, so the first one is just load immediate, and to do that we basically just do kind of like what this one does down here. We fetch a byte from, we're fetching a byte, takes the next byte from the program, and we OR it. We AND it. We AND it with the A register, and then we call load register set status, I believe. So that's kind of a, I suppose, yeah, we'll keep it named that because we are technically loading that register with something. So yeah, we just load register set status with the A. So you can see that load immediate and immediate are kind of almost exactly the same thing. So let's just see if we got any tests to pass by doing that. And it's gone from 37 to 36. So something clearly passed in there, did it? Yeah, test logical and on register immediate. That passed. So there you go. So a success. So I suppose we just keep going. I suppose we can just do the OR version of that. And it's going to be exactly the same except it ORs. Is that right? What's wrong with that? Oh, it's called ORA or ORA. Should have 35 failed tests. Cool. And we can do the same thing with exclusive OR, which should be this and that. 34. So that's 3 done. So we're getting through them, but at least we've got, you know, a clear idea that we think we know these tests are going to work. We might have written the test wrong, but at the moment I'm not exactly sure. So maybe I'll just do next one. This one is and zero page. So this one should, I think we have a addressing mode for zero page, which just takes the address. Yeah, we do. Addressing mode zero page, which just takes the cycles and the memory. Does that give us a word back? Yeah, it does. It gives us a word back. And then we and the A register with the value from that address. Is that right? Is that how we do those? Oh, we had this load register thing for the other ones. Yeah, so this kind of made this our whole life a little bit easier. So maybe we'll do the same thing because we're going to use these all over the place. I think this just was to just simplify the fact that we had a lot of typing the same thing and we could get this wrong because we're typing the register the same each time. So instead of load register, this would be and register. And we'd read the byte and we would AND it with the register and a register with the value from memory. And in fact, do we really need to pass in the register because it's always going to be the A register anyway? So we could just call it AND. That could be a thing. Can we do it like that? Yeah, we can. So and the A register with the value from the memory address. So, and of course it does the set status thing for us. So in effect, we can just do that. That works, I think. It does seem to work. I think we've made a test pass. Somewhere a test has passed. Yeah, 0 page. So that has worked. So I'll tell you what, I'll do all these down here, because now we're going to get something very similar for ORA or ORA, and we'll call that ORA. Yeah, why not? And this one is exclusive OR. And I think we just need to write those. Or the A register with a value from the memory address. It does that. And exclusive OR. And the A register with a value from the memory address. Exclusive OR. Boom. So we just got 4 lambdas stuck in there now. And I think that is 3 more instructions done. We're not passing tests though. We're not passing as many tests as I thought. Oh, we've got flag errors. That's a problem. So we expected the negative flag to be true, but actually it's false. And I think that's because when I did the tests last time, I didn't really take into account that because you're ANDing ORing and exclusive ORing, you're going to get different values in that negative flag. So maybe I should fix this test now. Test logical op OR. Should I fix that test now? Or maybe I should just fix the test first. Logical op OR on immediate on 0 page. There it is. So yeah, so we're doing the same. We've written the same piece of code to do AND OR and exclusive OR. But the problem is that when it comes out the other end, because the A register can have different things in it, it's not necessarily always going to be 0 or always going to be negative. In fact, we know it's not going to be negative because of the way we set this test up. We can't ever be negative. But we possibly are coming out with 0 depending on the situation. So that's a bit of a weird one. So one of the things I could do is not test the negative flag, but then we're not really testing everything as well as we should. So I don't know. Maybe I could do this. I could do the logical op again, and it with the 0 flag. Oh, let's do that. I mean, this is a bit weird, but let's do that. So if we AND it with 1, so that's the 0 flag. So if the logical op, let's take this out of here, and we'll call that expected result. So we expect the A register to have that in it, and if we take the expected result and it with the negative flag, if that is greater than 0, then expected negative. Yeah, I think. So that's just saying whether we expect the result to be setting the negative flag, and then we can verify we can expect equal, I think, on this. Maybe that's right. So we're working out what we think the negative flag should be, because it could be different depending on each one of these things. We might have to do the same thing in all of these tests now. Yeah, and that's made those tests pass. So we did get different negative flags depending on the thing. Oh, hang on, no, it's not made them pass. Test logical op exclusive OR on a register immediate is, oh, so that one didn't pass either. That's the same thing, isn't it? Yeah, we've got the same problem in that test up here. So we've got expected result and whether we expect negative. So all these tests are a little bit wrong, but they're not so wrong that we can't fix it. That should pass that test now, I think. If I got the, oh, that's the wrong value though, isn't it? It's logical op with 84 and CC. Yeah, that is better. That's 30 tests passing. Yeah. So it looks like the tests are going to be a bit wrong, but not so wrong that we can't fix stuff, which is pretty good. But at the end of the day, we can just go and start implementing more of these. So I'll just do this, and if I add X, 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 so I can do the zero page X versions of these, and I go X, 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 I think that is 3 instructions implemented. And they're probably still going to fail. Oh, one of them passed. Which one was it? Yeah. Ooh. CPU A expected. Oh, there's something wrong with zero page X. Unless I've done this wrong. And or exclusive or. Yeah, there's something wrong with that test as well. So let's go find that. We do the zero page value from 42, we add the X register on to get to 47. It should be a 37. And the A register didn't contain the correct value. Again, let's just take this part out to start with, just so I can see it as well. So the expected result is that. So we expected the result 4, did we? Oh, because we're taking CC and 37 and we're doing AND. So we expect the A register to have 4 in and the A register has 0. What? What's gone wrong in here? There's something very wrong there. So let's just check that. Let's just do some sanity checking. CC, yeah, which is 1100, 1100. If we AND that with 37, CC and 37 equals 4. Okay, so that's right. So we do expect 4, but the CPU has got 8 in it. So why is that happening? Let's just check this is the same thing we had before. A register's got a 0 in it. Oh, that's a problem. that's the problem. This should be the A register. There we go. Right, so that test is bad. That was a bad test. Right, I was thinking, how could that be true? It's like we've tested these addressing modes before. Right, 26 failed tests. Yeah, I think that's all good. Oh, but that one should work as well. Oh, is that test bad as well? No, that test's got a proper X in it. I mean, it could be, yeah, it could be that we're getting these negatives wrong, so let's do that in there as well. Let's just make sure this is correct. It's the same values we're doing there. And the expected negative. Right, is that test any better now? 24, I think that did fix it. It's fixed something. Yeah, that's fixed it. Okay, onwards and upwards. Absolute is the next one. So let's just copy 3 of these again. And we go. Absolute, absolute, and absolute. And I think we've got an addressing mode for absolute. We do. So these all just get pasted in and we get to see what we fixed. What do we have? 24 tests passing. We've got 23. So this might be the same problem with the negative flags are not, these tests aren't correct. Let's just fix these now. Okay, mostly the same values in most of them. See if that fixed anything. 23 we were on, 21. I think that's right. I think we move on. Absolute X would be the next one, yeah. Which again, we can just copy these absolute ones and we can absolute X, 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 absolute X, absolute X, absolute X. We only got 2 tests passing. I think I would have expected 3 because this negative flag's wrong again. So let's fix that. What were we on? 19? 17. That's right. When it crosses a boundary. Oh, so the boundary tests are wrong as well. It's called boundary, is it? What was that test called? A page boundary. I'm looking for a page boundary. There we go. When it's crossing a page. Giving all these things different names just to make it annoying. It's the same numbers again. Down to 15. So absolute Y. Next one. Again, we could just copy all these and we can change the X's to Y's. Oh, is there something wrong here? Why is that? Why does it think that's not defined? Case 9 already used? Where? Something's wrong here. Okay. Case 9 is already used. Have I got? Oh, it's 39. No, it's not. 39 is there and 39 is there. That can't be right. And absolute Y is 39. So this ORA absolute Y cannot be right. Why is it saying 9 when it's 39? Although that is in hex, but it did just say 9, didn't it? Case value 9. Oh, is it the 9th case? No, I don't know what that means. That is the crappiest error ever. Absolute Y is 19. Okay. So absolute Y is still failing. 2 have passed though. It's the negative flag again. I was suspecting that some of these tests would be wrong, and it turns out they are. Right, what are we down to? Ooh, down to single digits. We've got indirect X. Let's do the same thing again. And if these tests had been right, this would just pass, but it's not going to. Yeah. It's got, ooh. Oh, this looks like another bad test. Oh, is it that one? Absolute Y, yeah, CPU is wrong. EOR Absolute Y. Is this a bad test? CPU A is CC. Expected result FP. Why is it CC? That doesn't seem right at all. Looks like it didn't change. Did I mess? Just let me check I didn't mess these up. Oh yeah, I did. There you go. I messed that up. What have I done? Absolute Y, indirect X, but it wasn't passing. Yeah, indirect X was not passing. Instruction 0 not handled, because that's wrong. Right, let's get back to where I was. Okay, so it's just the negative flag test that's wrong. It's this. Yeah, okay, right. At least I'm doing. I was really confused there for a second. So I think this is going to sort it out again because we've got the negative flag test not matching up with what we had. Right, we had 8. We should be down to less than 8. 6. Cool. Right, now I'm back to indirect Y. Is that right? Yeah, indirect Y is the only one left. And it's got 6 tests. So let's do that one and then we are done. And that was really quick, even with all the problems. Let's copy the right ones. It's amazing, this giant switch statement is just getting bigger and bigger. Indirect Y. Indirect Y. Right, in theory, if this was a perfect world, that would all just pass now. We got 2 to pass. So we got the negative flag wrong, that's one thing. Let's fix that. I think I've got 2 sets of tests for this. Yeah, I'm crossing a page. Let's do that one as well. See what we get. See how much we won. Oh, look at that. There we go. So that was really quick. That was all of the, well, assuming they work, we think they work. That is all of the logical, most of the logical operations done, and exclusive OR and logical inclusive OR. So that's another 24 instructions. That takes us past 50 out of the 150 or so. Don't know where the rest of all these are. They're in hidden away in somewhere, maybe in there. No, but we're getting a bit further. So maybe next time I'll maybe do this bit test one. It's only got 2 addressing modes, and we'll just sort that one out. And then we've got all the logical operations. We'll actually have all load and store, all stack operations, and all logical operations. That'll be pretty good, and all the jumps and calls as well, actually. So that's pretty good. Getting a little bit further. So I'll move on next time. Maybe just do the bit shift next time. Maybe do a bit more. Who knows?